So here we start Chapter 5, Part 1, Systems of Linear Equations. And in this chapter, we're going to be seeing not one line or not one equation, but two. And the whole idea is to figure out when these two equations intersect, when they cross, and what that point represents. So to start out this packet, we're going to start with an introduction to systems of linear equations. And our goals here today are to write or solve them and to interpret the solutions. So a system of linear equations is two or more equations on the same graph. So there are three possibilities that can happen if you have this situation. If you have two lines that are on the same graph, the two lines will intersect and they will have one solution. And that solution would be where the 2 points, or where the two lines intersect here. This would be considered the solution. Or you can have a situation where two linear lines don't have any solution. We learned extensively about parallel lines, and we know that parallel lines never intersect, they never touch. So if we were looking at two parallel lines on the same exact graph, there is no solution because these lines don't touch, they don't cross. So this would be a situation where there would be no solution. Or two lines can be actually the same exact line. So imagine me drawing this line that's blue, and then I draw the same exact line over top of it. Well, that's not exactly over top of it. We have a blue line, and then say I draw exactly the same line over top of it, the red line. Now these two lines cross at every single point because they're the same exact line. So this would be an example of infinite solutions because all of the solutions are at every single point. So every single point is a solution. So what it says here, looking at the graph, you will notice that the two lines intersect at exactly 1 point on the left. And that means that there is one exact ordered pair that would make this solution true for both equations. And this is actually something we did sort of at the beginning of the year when we started with equations. We tried to see which points would be solutions to the linear equations. So let me erase this stuff and scroll down. Okay, so looking at example 1, we are trying to determine whether the ordered pair is a solution to the linear system. So the point we're trying to verify is 2, 5, and every ordered pair is in x, comma, y form, and we want to see if this point is a solution to both the equations. So in this section, we're going to be seeing not one, but two equations, and we have to see if 2, 5 works for both of them. If it works for both, then yes, it is a solution. If it works for none, then it's not. If it only works for one, then it's also not a solution. So what I will do is take the equation x plus y equals 7 and 2x minus 3y equals negative 11, and I'm going to be replacing a 2 in for x and a 5 in for y. So this is going to say 2 plus 5 equals 7, and then I verify if that's true. Well, 2 plus 5 equals 7, so yes, this works. That is true. For the second one, I'm doing the same thing, but this will require a little bit more work. This is going to be 2 times x is 2, so I'll replace 2 in for here, minus 3 times 5 is y, so I'll replace that. And then I have to do some algebra and see if this is true. Well, 2 times 2 is 4, 3 times 5 is 15, and 4 minus 15 is negative 11. So this one works as well. Since both of the equations work, that means that 2, 5 is a solution. In the second problem, now we have a different ordered pair. The ordered pair you're now using is 3, 2. So you're going to replace in 3 for x and a 2 in for y. And you're going to do that for both of those equations. If it works for both, then that is a solution. If it works for one, it is not a solution. If it doesn't work for either, it is not a solution. So go ahead and try that last problem there by substituting both of those numbers in. Alright, so to go over this problem, what we will do is take 3, 2 and replace it in for x and y for both of the equations. So it will turn into, since this is x and this is y, the equation 2x plus 3y equals 12 will be 2 times 3 plus 3 times 2, which is kind of confusing. And let's see if that equals 12. Well, 2 times 3 is 6, 3 times 2 is 6, 6 plus 6 is 12, so yes, it works for the first equation. The second equation is 2x plus 4y equals 14. Replacing in a 3 for x and a 2 for y. We have here 2 times 3, which is 6, plus 4 times 2, which is 8. And 6 plus 8 is 14, so it works for both of these. That means that 3, 2 is a solution. Okay, so that's how figuring out if ordered pairs are solutions work. If you flip this over to the next page, we have some keystone practice problems that are all about systems of linear equations. So we have number 1, multiple choice question. Number 2 is as well. Number 3 looks like it is kind of like an open-ended. There is no multiple choice. And then we have 4, 5, and 6. So what I want you to do, please, is complete numbers 1 through 6 across those 2 pages. I'll give you maybe like 6 minutes, and then we will go over these together as a group.